Let's have another example. Or actually, this might be more of like a tips and tricks. Whoops. I want to talk about these types of problems where you're given an equation and you're asked to decide if it has integer solutions. Or usually you're asked to decide that it does not have integer solutions. So we've talked about this a number of times. And what is the idea? The idea is to reduce ax squared with by squared. So reduce your equation mod m for some m. And show it has no solutions mod m. And conclude it has no integer solutions either. And remember, the way you get from here to here is that if you have an integer solution, it's sort of the contrapositive. If you have an integer solution, then you can reduce it mod m to get a solution mod m. And the contrapositive of that is that if you do not have a solution mod m, then you must not have had integer solutions to start with. So I have a couple comments. Maybe I'll write down some explicit examples, but let me give some comments first. So here's a tip. Make sure it has no integer solution, it has no solutions mod m. So if you are a little bit not careful, then you can find yourself in a situation where you reduce your equation mod m, you observe that it has no solutions, and you conclude that there are no integer solutions. But if you're not careful, you can sort of miss this and overlook a solution mod m. So be careful in this step. I see people getting tripped up by this step sometimes. For example, can we give an example? I mean, because modular arithmetic works slightly differently from integer arithmetic, it can be a little bit hard to see immediately if there are solutions or not. So what is a good example to give? Right, let's give the example from the homework, which I think was, if we reduce mod 5, we have something like x squared minus y squared congruent to 2 mod 5. So we know that in this situation, 0 squared is 0, 1 squared is 1, 2 squared is 4, 3 squared is 9, which is 4, and 4 squared is 1. And you can see that there is no combination of 1 minus 4 that equals 2. So maybe you conclude that there is no solution mod 5. But if you look more carefully, so 0 minus 1 is, you have to worry, I mean, the problem is that you can miss things if you don't think about the like wraparound effect of modular arithmetic. So this is negative 1, which is congruent to 4. And 0 minus 4, similarly, is negative 4, which should be 1 if we want to give it the unique 0 through 4 thing. And so you can see, actually 1 minus 4 is congruent to 2, because -3 plus 5 equals 2. So this is -3, and this is telling you it's congruent to 2 by adding a multiple of 5. So there are solutions. Even if it did not seem like it at first. So this is a little warning that I want to give you. Be careful when you're checking if there actually are solutions or not. Okay, and then the second tip that I want to give you, tip 2, is how do you choose a modulus? So in the outline to this problem, I said you're given something looking like this, and the idea is to reduce it mod m. And then you observe that it has no solutions there, and you conclude what you want. But the problem, as we have seen here, and as we have seen other places, is that not every m will work. So for example, as we saw above, x squared minus y squared equals, we could just take 2, but let's say 7. This is going to reduce to this equation mod 5. So this, let's see. Yeah. So this has solutions mod 5. So 5 doesn't work. But it has no solutions mod 4. So 4 does work. Maybe I will not check this for you, but you can check it for yourself if you are skeptical. So the point is that if you start from some equation in the integers, if you reduce it mod m, it will not always have solutions or always have no solutions. It might sometimes have solutions mod some m and no solutions for some other ones. So how do you find, if you're trying to show it has no solutions, you want to find one of these. And how do you find them? So I want to give 2 tips how to do this. And what tips do I want to give? So the more straightforward way, without having to think too much, is just to try a couple of things. So maybe you try mod 5, and it doesn't work. Then you try mod 4, and it does. So this is, basically one way you can do it. Just try a few things out. But another way or maybe, and also let me say, if you're going to approach it this way, then you are also going to keep in mind a good list of things to try. And I guess the main thing I would say along those lines is that you should just try small things, because the bigger you choose your modules, the harder it is going to be to check. So usually you're going to be using like 3, 4, 5, etc. Or maybe not even etc. Probably just 3, 4, 5. Hopefully one of these will work. If they don't, you may have to resort to some drastic measures. But those ones are a good place to start. But another way, which in some cases will be much more helpful, is if you have some equation like this, consider what A and B are, and maybe also C, but especially A and B. And what I mean by this is, can you choose M so that one of them disappears? So for example, if you have some equation like this, then regardless of what M you choose, it's always going to basically look like x squared minus y squared on this side. So maybe it's not totally obvious that 5 is going to work or not, so you try 5 and it doesn't work. Whatever. But if you have some equation like x squared minus 5y squared equals 7, now you can look at this term and see that reducing mod 5, well, this will be 0. So this kills the minus 5y squared term. And you just get x squared congruent to 2 mod 5. And this makes it much easier to solve, because as you can see in our, annoying be careful tip up here, when you have to worry about combinations of things, first of all, there's a lot more to check. And second of all, it's a lot less obvious what you can get. But in this example, since this term went away entirely, now we just have x squared congruent to 2, and we know that squares mod 5, you can work this out for yourself, but we've done it a couple times, and we did it right here. They are 0, 1, and 4. So we can immediately look at this, and it's much more clear that there is no solution. So these are Sanders' top tips for proving that there are no solutions by reducing mod n.